Here's pre-calc. This is problem number 8-121, and it says here, let's autofocus. Two forces are being used to lift a 100-pound box as shown in the diagram at right. Can they lift the box? Use vector operations to justify your answer. So the only vector operations that we've really known is adding the vectors, and we get the resultant force. So let's take a look at this problem and try to figure out how to set it up. So let me do autofocus again. So I just redrew the diagram here, and I know that I can't like add or get resultants of vectors when they're in polar form like this. I need rectangular form. So I remembered that I can just think of this as a triangle, and 75 would be my hypotenuse, and I can use my SOHCAHTOAs on it. Like if I want the x, like if I want an x comma y, I can use, for x, I can use cosine, because cosine is adjacent and hypotenuse. So I would have cosine of 50 equals adjacent, which will just be my x, over hypotenuse. But if I multiply both sides by 75, I can just write that as 75 cosine 50. And if you use that same reasoning with sine, you could write it all out here if you want, but it just ends up being 75 times sine of 50 to get this side right here, because that's opposite over hypotenuse. And so then I just put those into my calculator, and I got the rectangular form, like an x and a y. And that's great because I can use that to add to this other vector. The other vector, I was confused because I didn't know why they wanted this first one to be left, or I mean to be negative, but now I think I understand. It's pulling in the opposite direction as this one. And so I think it's also, you can think of it as it's going left, like negative, like cosine's negative when it's going that way. But it makes sense to like subtract these since they're going in the opposite. Like one's pointing left, one's pointing right. They're not gonna add to each other's force, right? They're gonna subtract.
You might be the last with pain.
Okay. All right, and then and so we're going to turn that negative, and that's why that one's negative. And then sine's going to be positive because it's going up on sine, like the y values are going up. So I got that. So I have these two vectors, and I am going to add them up. And I think it probably doesn't matter about the x values because those aren't doing the holding up of the weight. Like the weight is pulling down. It's just pulling straight down. And it says, can they lift the box? So I think, I mean, we'll still add them up, but I think that it only matters really our vertical components. They're pushing up. So I added up this vector in rectangular form with this other vector in rectangular form, and that's called getting the resultant. And I got the resultant vector. Actually, this wouldn't be negative. This would be, I think this would be positive. That's positive. And then, so that is my resultant vector, and I want to know if it's going to be able to hold up this box. And so I'm going to add the box to what I have and see. I mean, maybe you can tell already that 72 isn't big enough to hold up 100. You know what I mean? 72 is the upward force, and this is the sideways force. So this vector is not pulling to the left or to the right. It's just pulling straight down. And so I end up with this number's negative, which means it's going to go down. It's not going to be held up by the sum of these two vectors. So we're going to say for our answer, we're going to say the two forces will not be able to lift the box. And I think that's pretty much all I have to say about that.